Hi, my name is Jackie Huang. My project is hepatocellular carcinoma survival status prediction. Let's look into this data first. There are total 165 observations and 49 attributes. This is the detailed information of the features. As you can see, there are like gender, symptom, alcohol. The first 23 are categorical features. And like age at diagnosis, grams of alcohol per day, there are 26 numeric features, but most importantly is the class. This is the category feature that I want to predict. 1 stands for patient survives, and 0 stands for patient died. So the purpose of my project is to build a computer-aided method to help the doctors when they diagnosis with the carcinoma patient, and also estimation of the survival status. Let's look back to the code. I did data exploration first. As you can see, the structure here is sort of unclear since the character and integers they mixed with each other. So I reconstruct the features first. As you can see, the new structure are more clear. The factor and integer, they are separated. Let's look into the visualization of these numeric features. There are distributional schools here, but I feel it doesn't hurt the model building, so I didn't deal with the distribution schools. And also did the detection of the outliers. I used the Cook's distance to detect the outliers first, and then I calculate the number of outliers for each feature. Here I showed the top 5 features that contains the outliers here. This is the name, and also the range of the numbers of outliers here. Since my dataset is small, so I didn't remove the outliers. I also did the correlation analysis here. Here's the result. I calculate the correlation between the survival status and with other 49 other features. Because I didn't deal with NA right now, so I just ignored NAs. And I also did data cleaning and shaping. I impute the features first. As I mentioned, there are category features. I build a mode function to impute the category features, and also tried 2 ways to deal with the numeric features. I tried KNN and also the mean, but I find that KNN performs better. So I just choose KNN, which K equals to 1, but I also showed the code that I used mean here. As you noticed, there's a feature called age at diagnosis. According to the number of the age, I just divide it into 3 groups, which are young, middle, and senior. So these are 3 new features. I appended them to my original dataset. Here's the code I did standardization. I used the z-score transformation to all the numeric features here. Because my 23 category features, they are already in 0 and 1, so I just need to transfer them to the numeric that I can create the dummy codes. I also did the PCA analysis. You can see the summary here. Look at the proportion of variance. You can see that no component is relatively big proportion of variance. So I plan to reduce features using other proper ways when I'm doing the model building later. Here's the code of my model construction and evaluation. I split my original dataset into 75% of training dataset and 25% of testing dataset here. I did 3 models, which are logistic regression, neural network, and also SVM. Here I can talk about the logistic regression first. I used this stepwise backwards elimination to remove the non-significant variables. And I stored the readout in seq. I built the logistic regression model here. And this is the summary of the model. I used my testing dataset to evaluate the fit of models. Here's the accuracy. And I also did the interpretation of the readout. This is the function. And this is the 95% of confidence interval of all the selected features. Later, I did the evaluation with 5-fold cross-validation, and I calculate the accuracy of each one, and also calculate the average of this model, which is not bad. And next, I did neural network. I also used the package neural net, which is very useful. And I built the model, use all the features. You can see here's the evaluation of fit of the models. And the accuracy I calculate here. I also applied 5-fold cross-validation. Here's the accuracy for each one and the average. And the last one is the support vector machines. Here's the code that how can I build the model, and look into the model I created, and also use my testing dataset to predict and calculate the accuracy here. Since the SVM is a margin-based classifier, is seeking for maximum of the margin, and the dependent variable to predict is a category variable. So it's a bit hard to apply confidence interval analysis here. But I still did the 5-fold cross-validation. Then I calculate the average here. It's pretty good. And next part is tuning of models. I just changed some parameters here, as you can see. So the next is the comparison of the models. Here I just used AUC to check the performance of all the 3 models and compare with each other. Here's the result. You can see according to the AUC value, the performance is logistic regression better than the neural network, better than the SVM. So this is my project, and as I mentioned, I want to create a computer-aided method to help diagnosis of HCC, and I feel my models performed well in this project. Thank you.